Hello again, Danielle here from Blackrock Castle Observatory, and today we have a very special guest with us out from CIT, Dr. Josh Reynolds, and we've had some very exciting news being published in the Nature magazine.
Nature Astronomy.
Nature Astronomy.
That's it, yeah. What we've managed to do with our instrument is we've managed to find a technique that will allow us to measure the diameter of stars with much higher precision than ever before.
Okay.
So that is one exciting thing. It's a very exciting piece of news.
And how is it different from, because I know there was this technique is a little bit different than how the telescope is normally used. So this was done using the VERITAS telescope, and it's one or is it multiple telescopes?
Well, let me tell you a bit about VERITAS first.
Okay.
VERITAS is used for very high energy gamma ray astronomy, and it's been called oddball astronomy in some respects.
Oddball astronomy.
We can actually get the gamma rays to interact with the atmosphere. And we
Okay.
see flashes from the gamma rays. We don't detect the gamma rays directly.
Okay.
So this has been up and running for about 10 years, a little over 10 years at this stage, and we've been mapping out the sky at very high energies. So much higher than the normal X-rays or gamma rays that you come across. So we've one of the bright sparks on site decided, hey, let's make a couple of measurements in the optical region. And what we did was we managed to repurpose the telescope to actually use it to measure the optical diameter of a star. Now the technique, the way that it works, is we managed to catch an asteroid passing through the field of view of the star, and we could take data at a very high rate, and on that basis, from the shadow cast by the asteroid, we could estimate the diameter of the star to very high precision.
Okay, so you're waiting for something to move in front of the star.
That's
So
correct, yes.
how many times does that have to happen before your data is complete?
Once off. Now what we have is we have 4 telescopes, all 4 of them are running in parallel.
Okay.
And what they do is they take a measurement every 3 milliseconds, so about 1,000 measurements per second, and it can measure the light coming from that star. Now as I said, the eclipse, which only lasts a couple of seconds. But with this instrument, with the 4 separate channels of information, we can actually outperform a lot of the larger telescopes due to the fact that the diameter of the mirror is so wide.
Okay, and so that I was reading a little bit about how that has a lot to do with why these telescopes are normally used for gamma rays and not usually used for optical. It has
That's
to do with
correct,
the
yeah.
mirror size.
Exactly. Now the mirror itself wouldn't have massive precision, you know what I mean, and about 0.15 degrees is 4.5 max. But we're measuring timing here. It's the timing that's really important, and they're giant light buckets. So what they can do is they can actually scoop up the light on an unprecedented scale compared with normal telescopes.
And you have a painting of
I do
the
indeed.
telescope?
This is the VERITAS site. It's based at Fred Lawrence Whipple Observatory down at the base camp of Mount Hopkins. We have 4 separate reflecting telescopes. Each of these is 12 meters in diameter, and at the focus we have a very fast camera consisting of 499 photomultiplier tubes. Now these guys can take pictures of a billionth of a second. So effectively it's probably one of the fastest cameras that's out there in terms of its data determining capability. Now what we did for our experiment is we swapped out the middle portions and we put in some additional electronics that would allow us to measure the light from the star at very high time signature fidelity. And from that information we can actually look at the diffraction patterns generated by the asteroid as it passed through the field of view of the star, and from that we could get a very precise measurement of the diameter of our star.
So now that you've been published, how do you feel?
Oh, it's very exciting.
Yeah.
What really excites me is the fact we've managed to repurpose these instruments.
Yeah, it's
Like they
really
were
exciting.
built for gamma ray astronomy, and now we're doing some real optical astronomy.
It's really
And-
cutting edge of
Oh,
astronomy.
no doubt
yeah.
about it. And as I say, to get a publication in Nature Astronomy, there's great kudos associated with that.
Definitely.
As I say, it's a new technique, and we can outperform the normal techniques by at least a factor of 2 in
Absolutely
terms
fantastic.
of measuring the diameters of the stars.
Well, congratulations, and
Okay.
thank you so much for taking your time out to come and speak with us here today
Right.
and showing us beautiful telescopes that you have. And good luck on your upcoming trip.
Okay, thanks
Hopefully
very
get
much.
another publication.
Fingers crossed. Fingers crossed. All
Thank
the
you
best
so
now.
much.
Bye.